Okay, so this is how to draw an FBD for all three different cases. I'm gonna chop first. I'm gonna start with the simplest case, and it's for when an object is on a horizontal plane. Okay, when an object is on a horizontal plane, you take the FBD, you start أول شيء with your y-axis and your x-axis. Okay, you're gonna label them y and x, always y and x, and you're gonna start. أول شيء, you're always gonna start with your weight. Okay, start with your weight going vertically down. You always put your normal push. Okay, n with the vector symbols. Okay, the normal push is always perpendicular to the surface. Since it's perpendicular to the surface, if it's going up, that means normal push will be up. Okay, type. If it's accelerating to the right, and they mentioned that it's a rough surface, or they mentioned something to do with friction, you'd always put that friction is in the opposite direction of motion. If they never mentioned a direction, just choose any direction for the force, and the friction will always be on the opposite direction. Let's say finally they said that there's a force like this at a 30-degree to the horizontal. You're not allowed to keep it like this. You're supposed to label it Fx, and over here, Fy. That's the first case. We'll call this case 1. Okay? This is for an object on a horizontal. Let's say now you have an object that's hanging between these two ropes. Okay? These are the two ropes. This is the object. Again, you would start with your y-axis, and then your x-axis. Label them x, y, and then start. How will she draw your weight? Since it's hanging, there's no normal. Okay, since when you have strings, there's no normal because there's no surface. So what you're gonna use? You're gonna use tension. Okay, the first tension is gonna be going up to the left, right? So it's gonna be up to the left, like. And I don't know, we'll just call this random angle alpha. We're gonna call this T1. The second tension is going down, right? So we're gonna put it like this. We're gonna call this angle, that's called theta. Okay, we're gonna call this T2. You always, whenever you have an angled force, you resolve it into components. T1y, T1x. Okay? Arrows, arrows, arrows. This is just so you guys know in case it comes in the written. T2, it has to have T2x and T2y. Okay? This is for the case 2 of hanging. Case 3, if it's attached to a surface that isn't a horizontal. Let's say it's attached to a surface like this. This is our block M, right? If it's attached here. Again, same thing. You're going to label your axis. Arrows, arrow, 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 X, Y. Okay? Your point here, you're going to start with its weight. And if they said it's at rest, that means there's something that's stopping the weight from pulling it down. So you'd say that it's friction pulling it up, right? Always understand how the forces work, please. And then, since there's a surface, there's going to be a normal reaction. But the normal reaction is going to be up because is this perpendicular? No. Perpendicular to the surface it's being attached to. How would be a right angle? It would be a right angle if it's going to the right. Okay, so that means normal push N is like this. Vector symbols. This is case 3. The last case is the inclined plane case. Okay, the inclined plane case is the one that caused some controversy. You have theta over here. Okay, and you have, this is your M. Okay, here's how you do it, and I did it wrong in my previous videos. You start with your y-axis and your x-axis, okay? When you copy your y and x-axis, you copy it bent, okay? You know the weight goes down, right? You copy it bent to the left. You don't make it straight. No, I used to make it straight, but since you're supposed to keep it bent, so you're going to make it like this. This is your y, and then this is your x. Okay? Your weight is going down, so we're going to label our weight going vertically down. What's the angle between the weight and the y-axis? It's theta. I forgot to put y-axis here. Y. Okay. You now have theta. Okay. There's a force that's stopping it from going down. Okay. On the x-axis, right? What's that force? Friction. It's stopping it from sliding down. Okay. Vector symbol. And always, you're going to have the normal push that's perpendicularly upwards on the y-axis. Okay. This is how to draw the inclined plane FBD. Okay, because many people used to draw it the way I did it, and apparently teachers are saying it's wrong. Just so if they suddenly decide to deduct marks in the final, you know what you're doing. Okay, I hope this helped. Thank you so much for watching. Okay, also don't forget before ending that you're supposed to resolve any, remember I told you any force at an angle should be resolved into its x component and its y component. Okay, make sure you do this. Okay, now thank you so much for watching and good luck.